Thank you very much again to everyone who has come along this evening, especially those who have made the effort to join us from Poland. You're all very welcome. This is the first in our series of International Mining Lectures, a lecture series where we invite other fellow mining institutes from around the world to come and give lectures for our members with the aim that we can get some excellent and exciting international collaborations going. We're delighted to have with us Professor Stanisław Prusek and Professor Alicja Krzemień from the Polish Central Mining Institute, otherwise known as the Główny Instytut Górnictwa, located near Katowice in southern Poland. Just so you know that our institute also has another online lecture next week, which will be one of our early career group lectures. So if you enjoyed tonight's lecture, then do please join us for James Heslington, who will be talking about sinking a deep mine shaft into the Zechstein Age polyhalite deposits in North Yorkshire. For those of you who haven't come across our institute before, we were founded in 1852 by the most important contemporary northern scientists and engineers for the prevention of accidents in mines, and we've been going strong ever since. Today, we are the Royal Chartered Institute for Engineering, Science and Technology in the north of England and have a lot of great things going on. So if you're interested in more of our events, do please take a look at our website and social channels. We have a range of interesting lectures and events held in the UK, with many of our events also available online. We hold social events in Newcastle for our members, as well as local and hopefully soon international field trips as well. We're certainly looking forward to visiting Małopolska and Silesia in the coming years. If you're interested in joining us, wherever you are in the world, then do please visit our website and send us a membership application. We do enjoy hearing from our international members about their exciting projects, wherever they happen to be. All that's left now to do is to hand over to Professor Alicja Krzemień, who will be giving tonight's lecture. But before we do, all I have left to say is, w imieniu naszej instytucji jestem zachwycony powitać Pana i Pana współpracowników. Dziękuję za Pana czas i za akceptuję naszego zaproszenia, aby wygłosić taki interesujący wykład. Alicja, over to you.
So, good evening, ladies and gentlemen. For me, it's really a pleasure for being here with you, and thank you very much for the invitation. And today I have a pleasure to give you some brief information on this, what my company is doing lately. So on behalf of my boss, Stanisław Prusek, who is with us today, and myself, I would like to talk a little bit about green energy transition, about the ideas that my company has towards leveraging competitive advantages of coal mines. First of all, I'd like to say that, as it was mentioned, my company, Central Mining Institute, known as GIG, we are located in the south of Poland. This is the region called Upper Silesian region, and we are in the center of this region that is still with the predominant activities related to coal mining extraction. So, talking about my country, we are still producing over 55 million tons annually of coal, and our energy production is in more or less 75% depending on coal. So as you can see, still coal plays a really important role in our country. But on the other hand, we understand perfectly that we are a part of the European Union and we follow the decarbonization path. So we are trying to develop interesting projects that could help our industry, but not only our industry, to deal with the problem of transition, which I can call a problem. So just a couple of words about my company, just to introduce you to this, what we are doing. 3 slides in short to tell you that our proper name is Główny Instytut Górnictwa. In English, we call ourselves Central Mining Institute, but we are known both in Poland and abroad as GIG. We are a research institute. We were established in 1925, and now we are subordinated to the Minister of State Assets. But we also work not only like a research institute, but also like a private company, because we do a lot of projects for the industry. Talking about the employees, we have more or less 470 people working with us, among them professors, full title professors and associate professors, as well as almost 100 of researchers with PhD title. We are a notifying body of the European Union with the range of different directives, mostly for explosive, for civil uses, for electrical equipment, for use in potentially explosive atmosphere, for machinery. So we do a lot for mining still, but we are also working for different types of industries, and we are just supporting them with different projects, with different certificates. We also have a scientific council, which means that we are authorized to work a little bit like a university, although we don't have the first and second grade students, but we can grant the degree of doctor, so PhD, and also something that is very typical for Poland, what is another title, it's a doctor habilitated, so a habilitation title. So this is what we do, and some figures for you to a little bit to understand how we work. Figures from the year 2021. So almost 4,000 research works and contracts for over 1,500 clients. This is what we do. I talked about the number of our workers, but we also publish a lot. So to over 200 scientific publications in different journals about the outcomes of our work. The revenue is more or less something like 20 million euro per year. And we have 19 testing laboratories where we are doing different research work, but also things like projects for the industry. And things that I'm very proud of is that we are running almost, here we have a figure of 59 projects, I mean research projects, and among them 37 international. So we are still trying to get different funding, both national and international, to support our work and to get new results now, mostly towards the issues of the decarbonization and post-mining, but also other things that we are doing, other activities. And the last slide related to my company is that for you to see that we are just doing not only mining, so mining and geoengineering, of course, but also environmental engineering, which is a really wide area of activities that we are developing. We also have clinical center, and we also do a lot on occupational safety in the industry, as well as material engineering. But on the other hand, as I've mentioned, we do certification and attestation, and some range of activities related to training and education. So this is also our main topic of interest. But during today's presentation, I was given, let's call it 45 minutes, and I already used a couple of them just to introduce my company. I haven't introduced myself because I was asked to send my short biography. So I suppose you know that I work for this company. I worked for this company over 10 years. Previously, I was working at the university, and my field of interest is risk assessment and industrial safety. I'm by excellence, I'm a mining engineer, and I'm involved in different projects, among which I would like to present you 3 of them. Only 3 of them, as you've seen, out of 59 that I showed you on the previous slides. So 3 projects that are just focused on transition. The first one, 3 of them funded by Research Fund for Coal and Steel, so European funds. The first one, it's a companion measures project, so we call them a little bit like a soft projects. It's about the synergistic potential of end-of-life coal mines and coal-fired power plants, where we are looking for ideas about the update and readoption of territorial just transition plans and how to use this infrastructure to develop different business models. Another two projects are research projects. So the GreenJOBS is about leveraging the competitive advantages of end-of-life underground coal mines. So in this case, we are talking about specific site-specific research developed in Poland, in Spain, and in Slovenia. I will talk a little bit in further slides about this idea. And finally, recovery project, we are very proud of this one because it's about degrade and transformed ecosystems in coal mining affected areas. So hopefully at the end of my presentation, I will show you a short video about tangible results of this project, which is about to be finished next year. So projects and our partners, as you can see in all these projects, we have both academia and also industry. I just put in blue industry, so we are working with Spanish companies, with Polish companies, and also with Slovenian mining companies. As you can see, also Czech Republic is just developing with us projects. So here are most of our partners in those projects, which are helping us to develop new ideas on transition. First of all, we say a couple of words about potentials projects, which, as I've mentioned, it focuses on taking advantage of the joint potential of end-of-life coal mines and coal-fired power plants. What we want to do is to show what types of new economic activities and of course jobs could be developed in coal regions in transition. The first, I wouldn't say the problem, rather challenge, was to look for the opportunities. I mean, we are closing a mine, we are closing a coal-fired power plant, and we have to give the ideas how to develop new business models that would rely on renewable energy. Also on the idea of the circular economy and with the use of scale energy storage, which in this case would somehow guarantee a sustainable and combined use of assets and resources. So as this project is developed among Polish, Spanish, Greek and German partners, and in this project, we were analyzing both underground coal mines and surface coal mines. Mostly in case of surface, they were Greek coal mines, and we were looking for some. We call them actions here, but technically they are scenarios. So we are thinking about 14 different scenarios. Of course, looking at them, you might say, why not another one? There are many of them. We were just considering the ones that our partners in the project and stakeholders involved together with us in this project would find feasible, interesting, and possible to be applied. So you can see on the list ideas like virtual power plant, green hydrogen plant, eco-industrial park, but also you can see cultural heritage. I know that in UK, you have very good examples of this way of this business model. Also floating PV panels at flooded open coal mines. This one rather in Greece, but we were considering technically as one of the good options. And then you can see also on the list that not all of them are completely or mainly focused on renewable resources, because you can see here combined cycle gas turbines power plant. It's because some of them are needed to support the gridding. They have to be some kind of backup technologies. So that's why how we see them. You can also see some technologies that are not fully operational, like small modular reactors, but there's a lot on this topic, and we decided that maybe it should be added here as a possibility, seeing what kind of advantages has this technology. But also molten salt plant, hydro pumping open pit, or biofuels. When thinking about this project, we had to find a specific criteria that would allow us to evaluate these scenarios, these actions. So talking to stakeholders and brainstorming on the criteria that would be important. The criteria were developed before the aggression on Russia on Ukraine, but still we thought that the most important one would be energy security. and that one was put at the number 1. The second one was renewable resources, I mean greening, all types of technologies that would support business models relied on renewable energy and the idea of circular economy. Low investment barriers that would allow investments easily to be developed, but benefits also to encourage private investors to decide to invest into coal regions, which is not that easy, that we've learned lately. And then regional development, we were thinking about national development, but it seems that regional development is more important. That's why we changed this criteria. Finally, environment and job creation, which is one of the policies of European Green Deal. When thinking about the policies, we decided to go directly to European Green Deal, and we took 3 of them. No net emissions of greenhouse gases by 2050, economic growth decoupled from resources use, and no person, no place left behind. So now I would like to share with you the results. We used a specific software called Multiple, which is based on the idea of multi-criteria, and we just did the scoring of the actions, as I've mentioned, actions mean here scenarios, against the criteria. And we got the values using the knowledge of specific experts that could just give us really the feedback on how different technologies, different actions, different scenarios could be applied. Of course, in some cases, we've learned that we were evaluating them separately, but some experts would prefer to do that in kind of combination, and that's really how it should work, to use all possible advantages of closed coal mines or mines in the process of closure. Second, we also had to do the matrix, to fill in the matrix where we were evaluating policies with respect to criteria. So the values from 0 to 100 were given to 3 policies: climate, growth, and people, against the 7 criteria. And finally, we got more or less these results. And the results show that different policies, taking into consideration different policies, we should focus on different scenarios. So from the point of view of a climate, it seems that hydrogen production would be the most beneficial, both with hydropumping and both with molten salts. So those 3 technologies were highly rated, looking at them from the perspective of the climate change. And then when we are talking about the growth, the eco parks seem to be a very interesting option. Biofuels, this one is a little bit tricky because not all our partners in the project agree on that. It's because of the availability of the biofuels. That can be a very big challenge that will not be overcome in some countries, and molten salts as well. But when we are thinking about people and exactly these types of scenarios that would give us the opportunity to create jobs and to keep people from leaving the regions, then it showed that we need really a lot of staff to run the eco parks, for the idea of small modular reactors, and also for biofuels. So this is how we see it, and now we want to explore it further and to understand if some of them can be combined. Here you can see a kind of map showing you exactly this, what I said. It means separately which technologies got the closest to the policy of growth, people, and climate. So that's it's called an action policy closeness map. On the other hand, when doing this exercise, we realized that there are some other scenarios. We call them micro scenarios because they will not be able to use all the infrastructure, but they might be really interesting for the coal regions, for the specific mines, but they have to also, they depend on the specific needs or will of the coal regions interested in exploring these technologies. And as you can see here, we were able to define 10 types of micro scenarios, we call them this way, starting from batteries, recovery of resources from coal mining waste heaps. This might be a very good idea, but not interesting for all regions. Use of methane from the gasification units. It seemed to be interesting for the German case. Circular mining technologies for pumped water material recovery. Forest restoration, for example, at former open pit mines. This one was very interesting for Greece. Also something like large-scale information technologies infrastructure. But we also included here known technologies like geothermal energy. We put here gravitricity, so like a storage of energy in the form of potential energy using different types of weights, but also storage of energy using dense fluids or underground hydropumping. So those were the ideas that separately will not work, but combined with other scenarios may give very good results. And once again, this is exactly the same way of thinking that I presented before. So we had to do the scoring of micro actions with respect to the criteria, the same criteria, so from energy security to job creation, and we got the values. And it seemed that the second one, the same matrix that I showed you before, and now the results. So it seemed that for climate, the most interesting micro actions would be geothermal, would be fluids, would be hydropumping, and for the growth, batteries that would support greening, also geothermal, and dense fluids. And when we are talking about people and job creation, then also geothermal, dense fluids, and hydropumping. That was the scoring that was given by the experts. So from this set of different solutions, a specific scenario could be built for specific needs. So as I've mentioned, here you can see the same graph showing you that in case of people, we have different micro actions that would support this policy. Climate as well. With growth, it's more difficult. Technically, geothermal is the closest to this policy. What I've mentioned is that it's a kind of a generic exercise. So another project called GreenJOBS project is the one that really focuses on repurposing of end-of-life underground coal mines. Here we are talking only about underground coal mines, and there are 3 of them, one from Spain, one from Poland, and one from Slovenia. And 3 of them that could give a good site, and they are giving a good site for testing and building new business models. Business models based on renewable energy and circular economic technologies. And also the idea is how to maximize the number of green and quality jobs. So there are 5 competitive advantages of underground coal mines that we would like to leverage. First one is mine water, especially for geothermal and for green hydrogen. Of course, we are talking about good quality of water, so this is a crucial condition. Then we are talking about connection to the grid. For some technologies, it's very important that it's already there. So it can be adapted to inject, for example, electricity that we are producing. Then large waste heap areas. For some, it's a big problem. For us, we think it's an opportunity, for example, for installing photovoltaics or wind turbines. Also, some other ideas that I will present later. And finally, deep infrastructure suitable for unconventional, for example, pumped hydro storage using dense fluids, or maybe some other ideas. And fine coal wastes for 3 reasons. First of all, recycling into dense fluids. Second of all, for generating soil substitute for restoration. And I will just talk about this idea later. And finally, about rare elements, that it also is a very good idea that can be explored in this project. So a little bit about the sites for you to understand what kind of partners we have in the project and what kind of sites I'm talking about. First one is Bobrek Piekary mining complex in Poland, so underground coal mine extracting hard coal. Another one is the Spanish Ayer Barredo Figaredo mining complex, which is already abandoned and partially flooded. You can see here the level of water. I didn't mention that Bobrek Piekary mining complex is still operating and it's still extracting coal. And finally, Valenie mine in Slovenia. This one is also an underground mine, although the type of coal they are extracting is slightly different because it's more like a lignite. But they have a very big area where they are just having two beautiful lakes that are a consequence of their mining activity. So a couple of words. The first one is Bobrek Piekary. So depth of the extraction now it's over 900 meters. It is very close to the dense populated area. Many people from this region are working in the mine. As you can see, the number of employees are almost 2,000 people. The idea of the commissioning of the mine is foreseen for the year 2040, but I'm not sure about this date, considering this what is happening in Europe. And pumping capacity is over 5,000 cubic meters per day, and the water temperature over 25 Celsius degrees. So when mine will stop operating, there will be almost 8 hectares of available place for installing photovoltaics. So it's not bad. And on the other hand, the mine area has more than 2 hectares of forest with the possibility of installing wind power. So this one is very challenging site due to some restrictions and the location close to the densely populated area. The second one I'm talking about, this one is a mine in Spain. The depth of extraction was 355 meters, and it is also close to the dense populated area, but it ended its activity in 1995. So they still have problems. They still have to keep pumping water, obviously. So it's at the level of 4 million cubic meters per year, and the water temperature of water is around 23 Celsius degrees. That's why there is a geothermal installation with the installed capacity of 6 megawatts by means of a heat exchanger and heat pumps. So this is another place where we are looking for a slightly broader ideas of the transition and new business models. And finally, we have the third one, lignite mine with a depth of extraction over 500 meters in Slovenia, and the pumping capacity over 1 million cubic meters per year, and then temperature over 18 Celsius degrees. What is interesting here, that the area is very big. So they have capacity of over 30 hectares for installing photovoltaics, and they can also do that on the surface of the lake, so like floating PV panels. Also almost 30 hectares. The most significant potential is for wind turbines, as this is a valley and there are nearby hills, and the altitude is over 6 meters. Also, the number of employees is very high, so 2,000 people, and new jobs should be created for them. So in this project, among all the ideas, 2 are being considered. One is a virtual power plant. When the energy is produced, will be sold to the grid and used to power electro-intensive industries or other companies with a constant energy consumption that are located there. So, for example, like aluminum factories or wind data centers. And the second model is a green hydrogen plant, where renewable hydrogen will be produced by means of electrolysis from the mine water. In case of Spain, it's very easy because they have very good quality of water. In case of other locations, it might be a challenge, but we will try to overcome that, and to produce electricity from renewable resources. So this is more or less our concept. The first model of the virtual power plant where energy is sold to the grid. So as you can see, we are considering a combination of geothermal energy together with disrupted pumped hydro with the use of dense fluids. We are also considering rare elements from coal processing wastes, and also something we call them artificial soils. So it means producing soils out of waste, technically out of waste. So here's a waste heap, and also production of the clean energy then sold to the grid. This model will be applied, the business model will be designated to different locations, and we'll see how it works for Spain, for Poland, and for Slovenia. This one is the first one, and then the second one is green energy plant. Here you have more data about our idea. Technically, using the water, we want to produce hydrogen by using the electrolyzers, but also we were to use the possibility of geothermal energy savings, and to sell it as a geothermal district heating. And finally, we want to install something like photovoltaics to get the energy, green energy for the hydrogen production. Our ideas are also to put up to 5% of the nitrogen into gas, to do the gas blending, so to the grid, to the grid. And also part of it, try to store part of it, and maybe even develop a virtual hydroduct. That's the idea among these projects. And finally, the third project that I would like to introduce is a recovery project. I've mentioned that I will talk a little bit about the specific solutions. So here are different solutions. And one of them is the big challenge of the waste heaps, of spoil dumps, is commonly called. And in this project, we focus on land rehabilitation and ecological restoration of coal mining affected areas. We want to aim to accelerate the recovery of degraded and transformed ecosystem to a good ecosystem status. In Poland, this is a really big problem. We have a specific project called OPTPP that we are trying to do a platform to gather all the information about post-mining areas in order to be able to prepare a specific database for investors and for future projects. And it seems to be that some of them are extremely challenging, like the one that I will show you in a couple of minutes, the one that is under the study of this project. Because on one hand, we are developing ecosystem services concept. So developing, or more, maybe even, I shouldn't say developing because it exists, but applying ecosystem services into mining business to get and to evaluate the consequences of alternative courses of action to ensure that the capacity, to ensure that their capacity to provide benefits to society that is not diminished. So in this project, also there's a very specific solution that we call soil substitutes, where we are using waste materials from coal mine affected areas to produce something that would allow greening of this area. I encourage you to have a look at our article paper in sustainability journal, where we talk about this solution. Of course, in a couple of words, I will mention this, what we did. It's fully it's open access, so there will be no problem to get to this. So the idea was that the following coal combustion byproducts and other, so we're testing, we were just assuming that there is a possibility of using fly ashes from coal combustion, fly ashes from biomass combustion, decarbonization lime, or aggregate from mine waste processing, or sealing material from coal processing, or even sewage sludge, and also spent mushroom compost as some organic matter because we needed it. Just to make sure that we will be able to deal with very specific problems of the waste heap, big waste heap with high erosion and a very high acidity. Finally, in our laboratories, what's surprising that during the COVID time we were able to do all the work, and we were testing different techniques to enhance land rehabilitation. As I've mentioned, several blends were tested, and finally we were able to find the ones that gave a good results. So after testing it, we were able to undergo phytotoxicity tests of these soil substitutes, and we used Synopsis alba in the lab scale. And then we were able to finally prepare the concept of an experimental reclamation with the use of selected components. So here you can see two types of concepts. First of all, I'd like to mention the components. Finally, energetic slag, the carbonization lime, aggregate of the size of from 0 to 2 millimeters, sealing material, and spent mushroom compost were selected to produce the artificial soils. And we decided for two different approaches. One more expensive, where artificial soil substitutes of more or less 40 centimeters is separated from the mine waste by a specific sealing layer that is built from the dolomite aggregate, sealing material, and crushed dolomite stone. So this one. And much cheaper when we decided just to go for separating artificial soils by the mixture of soil substitute and mine waste in the composition of 50 to 50%. And this is exactly what I was talking about. This is the waste heap that where we are just doing our experiment. It is in Silesia. Well, technically it's not Silesia, I should say Małopolska, but it doesn't matter. It's in the region or in Poland where we are studying the plant vegetation. It's also mining close to the mine, Janina mine. And what we did is we selected this one because, as you can see, of a very intensive slope erosion and high acidic character of the waste. And the polygon was constructed with use of the material that I mentioned. You can see here some pictures, and we were able to do the seeding and plant some plants in the fall of 2020. So 2 years. And after 2 years, those are the results. Of course, not today, because in Poland today we had snow. So I guess the pictures wouldn't look this way, but the ones you can see here were taken in June this year. And we are really happy that we can see a lot of species that tolerate artificial soils conditions very well. There are some of them that they don't, but we are just analyzing why, and to propose for the mine and mining region what kind of rehabilitation techniques they could use to get good results. Our polygon test attracts also rabbits and some different types of small insects. So yes, so we have a lot of bees and other small habitats now. And now I'd like to invite you to see the video from this place. It will be only not even 3 minutes. And after this, I will just summarize my presentation. Thank you very much. That's all. I will just finish my presentations if you allow me. So I'm very happy. I hope you had a chance to see the movie. It's really from the place where we are testing salt substitutes, and it's not. We were not using any types of tricks to make it really so beautiful, and we were really prepared not to be successful, because that may happen always, especially considering that in some periods of time there was a little rain. But it seems that the soil substitute prepared and proposed in this project are sufficient just to convince some types of plants to grow and to make it once again beautiful, and bring some life to the place where nothing wants to grow. Even if some soil is being brought there, after a couple of years it is being destroyed by acidic leakage, so the water with very acidic water. So finally, to wrap up, I would like just to mention that I only talked about 3 projects of my company. I just wanted to introduce you to some ideas that we are trying to develop in the company. We are still working for the mining industry. Now we will start next year a very big project called REM, which stands for reduction of methane emissions, and it's because one of our biggest companies, JSW, producing coking coal, needs good solutions how to reduce their methane emissions. And they want to build something completely new, so installation for energy production from low, let's call it low methane content, from 20% to 30%. So we are still working for industry, or we are supporting industry, and on the other hand, we understand that we should look for other ideas that would support the greening. So thank you very much for your attention. I will be very happy to address any of your questions, and if not, here you can find my email and the email of my boss who is with us, so that you can write me an email, and I will be really happy to answer your questions. Thank you very much for listening. That's all from my side.
Well, thank you very much, Alicja. I think it was a very fascinating and wide-ranging talk on a number of things, and I suppose Steve and David can chip in and sort of see what we did here when we were busy closing down all our mines. I have a feeling that there was probably a lot less thought gone into it, but we'll just move on and say, does anyone have any questions?
If you don't mind, I'd like just to say that this is what I said at the beginning, that it's really a pity for me that we are not cooperating under the European projects because of the changes that were made, and let's maybe leave the issues of our government and this what happened, but I always remember that when we were developing different projects with UK universities, we really learned a lot, because you have more experience, you have more history of, I'm sorry for saying it, for good and bad examples that you were always sharing with us. And those bad examples was like a kind of lesson for us not to do it this way, because this is something that I think all the human beings are doing. We don't think that others' mistakes are good lessons. We just think that we should commit ourselves mistakes, and then it is very expensive. And I think UK has a lot of experience in transition. I have here my colleagues with me, and we are just, as I understood, the embassy of UK is just developing now a project on some ideas on transition. And I still think that UK has a lot of experience, a lot of lessons to share with other mining regions that are now facing the problems you had many years ago. Thank you.
Is that the British Embassy in Warsaw or the Polish Embassy in London?
It's rather embassy. The initiative was when I know from the embassy in Warsaw.
Ah, right. Okay. Yeah.
Recently, we had a meeting at our institute, and we discussed, let's say, the different possibilities of cooperation.
Mm. Oh, that's excellent. I think we've got both ambassadors in Cambridge in a few weeks' time, so hopefully they'll mention something along those lines as well. I think a few things that leapt out in terms of the small modular reactors. Is that in terms of nuclear, or is that another energy source?
That's a big issue because one of our companies, KGHM, producing copper. Yes, copper mine. And they introduced this technology and they said that they want to introduce to their mining. But that was I think that was more about showing that they want to go in this direction. But technically, we know that this technology is not mature enough just to take it and to introduce it immediately to any business model. So we just said, if it has so much interest and can give good benefit, they can have benefits, then we will keep it as one of the ideas. But of course, we understand not for 2 days.
Excellent. Yes, there's a lot of research going on in Britain at the moment. I think we do need to make a decision and actually go for these small modular reactors at some point. We're just trying to work out how and in what form. But yeah, incorporating them into maybe a mine system might be an idea. And then the other one, I think there was the molten salt. So is that's a sort of energy storage device, sort of technology?
It's not that developed here in Poland, but we've learned that it's very well developed in the United States, and there are many different types of running plants that we could use this knowledge and try to apply this energy for our use. So that was the reason why it was also taken into consideration.
And then there's the rare earths got mentioned. I don't like the term because everyone seems to use a different terminology for them, and it gets a bit annoying. But what sort of critical metals are there going to be in these things? I vaguely remember there was some work going on in Wrocław on sort of repurposing slag materials at some point. So what is there anything worth reclaiming from them, or is it too low grade?
But I'm not sure if I should answer this question. It's because I will say why. Because I'm a mining engineer and I have my own idea. I'm not criticizing any type of technology. I think any type of technology is worth developing. It's worth just giving a chance. But when we are thinking and we are looking at the technology from the perspective of the money and this what is feasible for the investor, then I have my doubts, and I would like just prevent from talking about this, because I'm more into reopening some resources, like for example projects that is being considered in Czech Republic, Synovec. So it's lithium and tin.
Yes.
Yes, that one is quite a good perspective. Of course, everything has changed lately due to the prices of this type of rare elements. If my boss is still with us, I would prefer to throw this question to him, because last week we had a very no, it was this week on Monday. Am I right? This week on Monday, one of our companies, known as the biggest mining company, decided to do a big event on the rare earth elements. So maybe I will just give this to my boss. Please, Stanisław, if you could just answer this question.
Thank you very much, Andrew. There is maybe proposal for our next meeting and for our next lecture, because it's as you know, it's very wide area of discussion, because in fact we are talking not only about rare earth elements, because this meeting, which Alicja mentioned, organized in our institutes on Monday, was about critical raw materials. And one of the main conclusion of this conference was, firstly, that it's not possible to do our, let's say, green transition in Europe without mining, firstly. Secondly, probably we won't be able to cover the huge demand on the critical raw materials because of, let's say, energy transition, because of the wind turbines, photovoltaic, electric cars, and many, many things. And the third conclusion was that majority of this raw materials we are mining in not in Europe, in China, in India, in Asia, in Africa, for example, cobalt in Congo, and etc., etc. So it's really very interesting, and we were able to see the figures and the very detailed information based on the European Commission reports or the reports of International Energy Agency. So yeah, it's not simple to answer the question. It's huge challenge in front of us. That's yeah.
Yes, we've been doing the same thing here. I'm not sure if we've still got the person from the British Geological Survey on, but certainly critical metals have been a hot topic since at least 2014, and there's been plenty of sort of UK government interest in going into it. How successful any of this is another question, but everyone talks a lot about it, and maybe we'll find a solution somehow. Certainly in terms of lithium, we've got a number of projects which are cropping up across the British Isles now, and then just in terms of one in Cornwall, they discovered a load of tailings, and they went, oh, actually there's quite a lot of lithium in the micas in the tailings, and so they'd quite like to go and remine all the tailings of all these old China clay pits. But then they discovered someone had beaten them to it and put a solar panel array over the top, and so they can't access it for another 100 years or something. So it was a sort of, yeah, they were thinking about things in the wrong manner, because they try and get the resources you can first before you put a solar panel array on top, and then you can't get them. So, lovely. Is there any other questions, or David?
I'd just like to say there's quite a lot of research in the UK about pollution, that when they stopped pumping, the water levels rose in the mines, and then the water started to flow out, carrying out heavy metals, and those heavy metals killed the fish in the water courses. And a lot of development's gone on into reed beds. So you create a lagoon, you fill it up with reeds, and they kind of capture the heavy metals. So that's research has been going on for a long, long time in the UK.
Yes, so certainly.
Yes, we had a project like this when we were analyzing the issue of water, and we learned that for different collieries, the problems are differ. So we were just analyzing water in Spain, and it showed that 4 times full cycle of water, it will just purify the water completely. But they have different types of contaminants than we had in Poland. So effluents were like analyzed there, and we were just looking for specific solutions for different places.
Yes, a lot of work's gone into capturing ochre coming out of all the mine waters as they come out. So certainly our coal authority has got a nice sideline selling ochre to businesses for all sorts of things, for paint and others, and geochemical purposes. It's interesting stuff. Lovely. Well, I suppose if there's a lack of any questions, the final thing I can ask is what's next for all these projects, and also certainly sort of mining in Poland at the moment. I know there's a bit of a debate going on about keeping coal going versus closing the mines down in Silesia and things like that. And moving on from, like, for further research, I know Britain is no longer part of these EU programs, but is there any collaborations you'd like to make in the UK?
I like the second part of the question and I can address it. The first one, I think I shouldn't. Sometimes I'm not politically correct, so I don't think I should say this is what I really think. So that's the problem with me. But yeah, it would be really great to have this possibility. I was just saying this at the beginning that it was really great. From the beginning when I just joined this company, and it was 10 years ago, I think almost 80% of the international project we had were with the participation of the UK universities, and there was always UK support in topics of any types of mining. So just showing good solutions, just showing lessons that we could just copy or just to try to apply. And that was, for me, it was always an added value. That's what I'm missing. Yeah. So this is something that stopped when UK, from the moment that UK was not allowed just to apply for EU funds under, for example, RFCS, because technically I'm talking about a research fund for corn steel, because money for mine research is there. That's why I'm mentioning this, and this was really a pity, and I'm thinking we are losing a very good partners in different projects. That's how I see. And if their questions are about mining, then maybe my boss can address them. Especially they are concerning the policy on this, if we will continue mining or not.
Okay, I would like only add a few words about, let's say, the history of the cooperation with UK, because I visited many underground mines in UK, and I had the pleasure cooperate with Lorraine. I'm very happy that Lorraine with us today, with Mr. David Bigby, Peter Artunian from Rock Mechanic Technology in 90s, and my first RFCS project was, let's say, with colleagues from Nottingham University. So really the long story of cooperation between, let's say, miners from UK authority, of course, I remember a few people from this organization. Lorraine is pure here. So yes, I'm also very pity that, let's say, the cooperation is not so easy like in the previous time. And trying to answer your question about the future of coal, I can only say that because of the war, yeah, in Ukraine, in fact, nobody is able to predict the future. Yes. Now I'm said the sentence like saying nothing, because it's obvious, yeah. And we are thinking about the future of our energy mix in the short and in the long term. In the long term perspective, it's almost impossible to predict something. In the short term, I'm sorry, probably we are forced to extend, let's say, the extraction of the coal, because in the last year, we prepared a plan, the plan of the closing of the mining industry in Poland until 2089. And now we are going probably to make some correction of this plan because of the situation on the market. And the nuclear energy was mentioned. As you know, we are going to build the first nuclear power plant in cooperation with US and maybe with South Korea, but it's nothing fixed in 100%. But this also there's a plan in our strategy of energy mix, but in my opinion, it will be in, I don't know, 15 years or something like that. So still we need a coal from this period of time. So for the short-term strategy, in my opinion, because it's my private opinion, probably we have to extend the coal utilization. I mean the coal, the hard coal, the bituminous coal, and the brown coal as well, because the brown coal is in our energy mix more or less 20% in case of the electricity generation. I don't know if I answer your question, but
oh no, that's fine. Yeah, there's a lot of uncertainty. There's been a few voices in Britain calling for the reopening of coal mines as well, and
I've heard about the Cumbria project concerning
just around the corner from Newcastle. It's a shame that a few of our members are not here tonight. The government may or may not have made a decision, but they certainly haven't told us about it yet. So it's again, that's got quite a lot of politics. It's very difficult to host a climate change conference in Glasgow at the same time you're trying to consider whether or not to open a coal mine. So no one wanted to say anything.
But Andrew, we are talking about a coking coal, so there is a main source of the steel production. So it's completely different story, as we know. So
yes. I mean, steel production in Britain is that's an entirely different topic, and it's a great shame to see all of our steel plants just slowly but surely being demolished. We do need to have a sort of strategic. It is a strategic resource. We do need our own blast furnaces. It's probably better just to sort of start from the ground up again, because to be far more efficient. But there's a lot of thought that needs to go into that. We can't just sort of sell coking coal to somebody else to make steel that we buy. It's just insane.
Okay.
No, but and it was interesting to hear about the aluminium smelters as well. That's something we could also do with another aluminium smelter. Lovely. Well, unless Lorraine wants to say anything, I think we can. No, that's fine. Lovely. Well, again, dziękuję bardzo. Thank you very much again for everyone who's attending, and also to Alicja and Stanisław and everyone at the Główny Instytut Górnictwa for coming along. We hope this has been sort of fascinating from both sides, and just because we're not in the EU doesn't mean we've left the continent of Europe. So do please keep trying, despite I know the funding problems, but yes, we're still here, and it's fantastic. And if any of you would like to come and visit us in the north of England, do let us know as well. But with that, we'll sort of draw this to a close. So thank you very much. You can start.
Thank you very much, Andrew. It was a pleasure, but I really enjoyed the discussion because there are many hot topics that could be just tackled, and there is a place for discussion still. And it would be really great to find some opportunities to continue cooperation. Continue, I'm saying continue because we've already did that, and there's a little short, let's call pause in this, what we are doing, like a break, but hopefully we can find other ideas how to do that. Thank you very much.